Well, good evening. Here we are again. I hope you noticed that I put some differing music on the test pattern and the opening screen so that you didn't hear the same 2-minute song looping over and over again. Anyway, I should say hello to Chris Stockdale, Dick Berg, Greg Kinney. Boy, there's a name from the past. Greg, that's amazing. And Sean Curry. I also look at my screen and see there's actually 11 people watching. So if there's other people out there who want to say hi, please give us a wave. That way we know there's interest and things going on. I hear an alert. It's coming all the way through my office door. Maybe it's some Amber alert or something. I got my devices out in the other room. Okay, let's get started. This is kind of a follow-on last week's with regard to scheduler, and I want to make a little announcement here. I've pretty much wrapped up 8.2. It'll be released as an 8.1.11, which will be a beta for 8.2, and the scheduler will play with ACP 8.1. Hello, Iris. Good, I'm glad you're here. You should know that I updated the Comet database at Great Basin. Paul's been really busy, so I did it for him yesterday. So maybe your Comet aiming will be better. Anyway, that should be out next week. I'm just testing now, and I got some installation things to take care of and so forth. And then by the end of next week, or maybe before, I'll have a beta out. So if you're interested in seeing some of the new features, that would be it. The forms are not going to change until ACP 8.2 comes out, because the forms belong to ACP because they're part of the web interface. Joseph, hello again, a repeat viewer. That's great. Okay, so one of the things that I did with the scheduler, and I'm just going to give you a brief peek at it, is kind of reorganize the help. I know it had gotten kind of messy, and so I spent a lot of time working on the help and adding to it. Now it's all broken up into more reasonable sections, and hopefully it'll make it easier to follow and learn what's going on. I still have a few additional pages to put in, but the Getting Started page now, it should get you started better, and the old Advanced Features page is gone. The one that had a big, long list of stuff in it, that's gone, and it's all broken up and hopefully in more understandable. I think this jammed up font here is a result of the video stuff turning off something in Windows, so I've got to make that font smaller. Anyway, I've got a few things to do. So I wanted to point out that that's new, and it'll be with 8.2. And hopefully it'll help new people get started more quickly and other people to find things more easily. Okay, what we're going to cover tonight are some of the more, I'll call them exotic or less frequently used features of the scheduler. Some of these things have come up more recently because we've been getting more university and other type of customers that are putting this thing through its paces. We have some people, professional astronomers from Southwest Research Institute, Dirk Terrell, and he's doing some pretty neat things. We have several people at the Great Basin Observatory doing different things, monitoring Tabby's star. Iris, I think she's doing comets. And so this stuff has come up, and I think I need to cover it because especially for some of these places, we don't have direct contact with the users because they're students and so forth. So hopefully you'll get a benefit out of this. First thing I want to look at, let me do my little switching job here, is timing. Let's see, there we go. Okay. In the web scheduler, this is the image series, but this works the same way in the astro imaging. I'm going to stick with the image series since science imagers typically do this more often, and they use the series forms. Hello, Yves LaRoche. Thank you for joining us. And so I'm going to stick with the series thing. Take a look down here in this section, timing and monitor mode. here's where some of the magic goes on. Paul Lucas, good morning from Australia. And thanks for saying hi. These two fields here, must run after and must run before. The basic usage of these is it will prevent a plan from being started before this time, or if it hasn't been run by this time, it'll get failed. So you can basically create a time window within which the plan is able to run, and outside of which either it won't get run ahead of time, or if it didn't get picked up and run because it was busy or whatever, it'll fail for that reason, missed its time slot. So that's the most basic usage for these two fields. Now, if you put a time in here, there's also some other things which I'll get to in a little bit with monitor mode, but if you put the same time here and here, and here's the format for the time, by the way. So if we could just copy that. So let's say I put, oh God, yeah, all right. What did I put in there? Oh, there's a, yeah, all right. So you see the form does validation, right? And if you put the same time in both of these fields and then click this fixed time, you'll get a warning. And again, these forms have been made more responsive, and they have some pop-ups that you won't see in your version of Scheduler until you get ACP 8.2. So this form has had a lot of work done on it. But it's basically telling you, don't use fixed time for asteroids or comets. That's what it's not what it's there for. We'll look at that in a little while. We have a full ephemeris generator inside ACP, so you can specify the asteroid or comet by its name, number, or designation. It'll go look it up and then calculate the ephemeris at imaging time, and that takes care of that. So it's saying don't use it for that. This thing is for timed and phase-constrained things such as exoplanet transits and that sort of thing. So I'm going to be careful to explain to you exactly what happens when you do this. When you click this, you'll notice the priority has disappeared. If I unclick this, see that? See how the priority field here just disappeared? It's going to warn you again. All right. With this in there on an observing plan, and again, if you have trouble with the concept of plans, observations, and image sets, I encourage you to go back and look at that video on that. I can't spend a bunch of time explaining that again, but the plan is the minimum schedulable unit. It can consist of multiple observations. The observations can even be different targets. And then in those observations, there can be multiple image sets, which represent imaging through different filters. So that's kind of how it all goes together. The point is the plan has to be able to fit in within a night, obviously, but you should keep these plans as short as possible so the scheduler has flexibility. But if you put these two times in there like this and hit fixed time, then at the beginning of the night, the scheduler will start that plan before it does anything else, and it'll carve that out. So it's going to run at that time with one caveat, and I'll explain that in a little bit. But the point is that the entire plan has been started. So each one of those observations, its time slot is spoken for. Now, the scheduler can fit things in between those observations if it wants to, and it can do autofocus in between there and all of that sort of thing. But the observing plan it has this marked in it for fixed time, that's going to it's going to run. Okay, so, but there's a caveat here. You have to tell the scheduler when you install it, you have to tell it a little bit about your observatory. So right up front and getting started now, here's a, here, I'm going to bring this out. Boom, okay, right here. What this is saying is that you need to make sure that in the scheduler, there's timing things. me bring that out, actually. I'm just going to start this up. I should have had this running. I apologize. Scheduler. Here. I'll just go to my desktop. There. Okay. Right here, when you're installing the scheduler, and this again is for engineers, and I said this thing wasn't going to be for engineers, but I want to make sure that you see this at least. This section right here talks about all of the different things that take time during an observation. So I'm not sure why you can't see my mouse, but anyway, it's under the ACP sequencer section. Those things need to be set for your observatory. And if you want to set them long, like if you think the rotator speed is 10 degrees per second, set it for 7. If the guider startup time 30, well, give it 60. Give the autofocus time 240 if you need to. German flip time, so make them long. The point is here that if you tell ACP that your observatory, if you can get those times right, then ACP can make a very educated guess as to how long it's going to take to run something. So here's where that becomes important. So you see, I basically have told you right in the getting started section, before using it, gets really important you set that stuff up. So, if, let me get back to this. All right, so when you set this up and the thing starts that fixed time plan, let's say that some big long time series or, some long astroimaging thing is running bung, 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 and it's supposed to run a half an hour, or you've got a half an hour of imaging and the ACP thinks that's going to take, instead of 30, 40 minutes for overhead. So if it's within 40 minutes of that fixed time, it'll go ahead and start that, expecting that it'll be finished before the beginning of that fixed time thing occurs. Here's the gotcha. The scheduler will not kill a plan that's still running in order to start that fixed time thing on time. So if you don't give the scheduler the right data when you install it so that it can make estimates of how long it's going to take to do a job, if it estimates those jobs short, it'll start a job too close to the fixed time and it'll still be running and it'll push that fixed time out and you'll miss your time slot. And that was a design decision that I was not going to kill a plan that's still running for a fixed time thing. Maybe that'll change, but at the moment, it won't do that. So make sure that you are careful and conservative in making those guesses, and that'll make the fixed time stuff start on time. I hope you understand. I hope that makes sense to you. Again, the chat thing on the side, you can ask questions or you can say, can you please explain that again or whatever. I'm keeping my eye on the time. It's only 13 minutes. I want to keep this at a half an hour or so, but every one of these things seems to run long because, we're talking about a lot of stuff. Anyway, so that's how fixed time works. And you use that really for things like exoplanet transits or when you have to catch an outburst of a CV when you know it's going to happen, that kind of thing. Phasing constraints, not for asteroids where you go pre-compute its position, and then tell it, okay, it's going to be here at 2 o'clock in the morning, so take it then. Hey, Tolga, hello, how are you? Thanks for joining us. I really appreciate it. So that's fixed time, and we can come back to that if somebody wants some clarification, but now we'll move on. All right, so we'll turn this off. Oop, I got to go over here. Boop. Okay. Now, the next thing is best efforts plans. Here's where things get kind of interesting. A time series will typically run a long time, and maybe you don't know how long it's going to run, or maybe you just want to run until something happens or until you hit one of the constraints. You want this thing to take, let's say you want to take an LRGB series every 10 minutes. And then while in between there, you want the scheduler to do other stuff. And then come back after 10 minutes and take another LRGB of the same target. Well, you can do that, and you can let that run all night. Well, how many of those LRGB things will fit in a night? I don't know, man. I can't figure that out. So what you do is you put in an observation with repeat count or several observations, enough to fill out the night and then some. So what happens is the scheduler will look at the plan and it'll look that it's got, 15 hours time span with a bunch of these 10-minute things in the middle, or, every 10-minute things in there. By telling it best efforts, what you're telling it is check the constraints on the first one of those observations of 4 images. Don't even look at what's downstream. It'll do those, keep the plan running. 10 minutes later, or however long the space is between the plans, or however you've got that set up, it'll come back. Then it'll check the constraints then. So if you've got a target that's creeping across the sky and you've told it that it has to be above below 2 air mass, okay? So it's creeping across the sky, and it keeps doing these every 10 minutes. Well, when it hits that air mass of 2, boom, that observation's going to fail. The plan now stops, and it'll say completed best efforts, and it'll be a successful completion, even though all of the observations in there didn't complete. I know that can be a little bit confusing, so if you need me to explain it again, I will do that. Will fixed time start late after pre-existing running plan is over, or does it fail? If the fixed time, the start of the fixed time here is after the pre-existing running plan has completed, then it'll start fine. I'm not sure I understand your question. If the pre-existing running plan has completed, then it will start. But it won't start 2 plans within the same time slot. So if it goes and looks at the fixed time plan at the beginning of the evening or 2 and starts them, then it'll never start another plan to cover that time that's spanned by the plan. So the only gotcha is if it starts at some other plan before that, and that plan runs long and pushes into the time slot for the fixed plan. That's where you run into trouble. I'm sorry I didn't make that clear before, and maybe I misunderstood your question, Dick, but at least I've tried to answer it here. Okay, going back to best efforts, I hope I've explained that well enough. Basically, normally a plan will execute or run all of your observations, which are, and each observation, by the way, is a job that's sent to ACP. So it'll keep doing those, and a plan can have multiple of those. It'll keep sending those to ACP, and if it runs out of daylight, if it runs into daylight or something like that, then again, you've made a bad estimate of how long it takes to do things. Normally, you shouldn't see it. Plan will extend into daylight, or it won't start it. So that estimate of the time overhead for ACP is important there too. But you can basically have it just accumulate data periodically throughout the night. And then when it reaches the point where the constraints are no longer satisfied, it'll stop that plan, and then it'll be successful. So that's what best efforts is all about. So basically it says here, okay if series terminates early. What you don't want to try to do is set it up with an image set with 500 images in it. It can't divide that up into pieces of work. So if you have 500 1-minute images, you got 500, or 5-minute images, you got 2,500 minutes of uninterruptible stuff there. So be careful how you put things together, and I'm happy to help you on the Comm Center put together time series plans. It's complicated, and I'm hoping that this will help a little bit at least, but I'm always happy to help, again, with your specific needs. And it's just about anything you want to do can be accommodated, but it's hard because you have to kind of twist your thinking around and not think I want to make sure things happen at certain times, but under certain conditions. And that's the way the scheduler works in general. Monitor mode. Here's where you can, that is right here, monitor interval. Right there. So if I put a 2 in there, what's going to happen is whatever I have set up on this plan, and it runs one night, 2 nights later, it's going to get requeued. Now that, and I don't have fixed time here set, so just bear with me here. Any plan, if you put monitor mode on there, it'll get requeued for the next night. Right now at Great Basin, that's being used to monitor Tabby's star. And they just go up and they have like a 45-minute or 1-hour plan where they get a bunch of data on that. And then the next night it runs again, every night. Nobody has to go in and requeue it because they use monitor mode, and it is automatically requeued that many nights later. Now, and this is new in 811/8.2, if you have a fixed time plan and monitor mode together, I put this in the wrong place. That's not monitor mode. This is monitor mode right here. So I'm going to close this because we had that open for best efforts. All right. Again, this is a timing and monitor mode. So right here, if I put 1 here or 2 here, that's going to run every other night. Now, if you have a fixed time plan in here like this, and you have a monitor interval of 2, this is new in Scheduler 8.2, it will advance the fixed time by 2 days exactly. Now, that's maybe not what you want, and typically not what you want, because these events don't run on a solar cycle, if you know what I mean. In other words, if the thing's going to happen at 1 a.m. local time one night, it'll probably be at some other time, 11:30 or 12 or something like that. So this probably has limited usage, but if you want something to be monitored at the same time and force it at a fixed time, it will do that night after night at that fixed time. Yes, Dick, if the running plan is running at the time the fixed plan is supposed to start, actually what happens is the fixed plan starts late. But it is an error. You'll get an error in the log, and it'll say missed its time slot. So you want to avoid having that by putting those conservative numbers into the ACP overhead stuff. That's the key. So yes, you have it right. That's exactly what happens. If a plan is already running and it extends into the fixed time slot, that fixed time, it didn't make it, right? It couldn't satisfy the requirement of starting at that time, so it'll fail. And it will not start a plan if it looks at what's out there. Remember, it always looks at what can I do and then what should I do. In the what can I do part, if it looks and sees, and it'll calculate how long it thinks it's going to take to do a plan, and if that plan it thinks it's going to take longer than what it can fit before the fixed time thing, it won't start it. So the only time you'll get this is if you lie to the scheduler and tell it your observatory does things in less time than it actually does. So again, it's really important to get that stuff right. Once you do that, and you can make it a conservative, so there's 3 minutes here, 4 minutes there, big deal, right? But as long as you get that right. I hope that made sense. All right. So monitor mode is really cool for things like I was saying, where you want to go back and get data on night after night after night. Well, how long does that last? And it says here, so many days, requeue every n days forever or until must run before. Sorry, I'm popping this mic. Let me get this out of here. Okay. That must run before. So monitor mode, let's take this out of here. Here on a fixed time thing, you may have, so 12:30 or something here. All right, in this case, it will run every other day until the 30th of December, and then it won't remonitor after that. So that's the idea, is that the must run before is used with monitor mode to determine when the monitoring ends. And I noticed, I think I saw a picture from you, Dick, that you are actually using this right now, which is cool. High cadence operations. All right, so this is kind of kludgy, and I apologize for this, but there are some options that you can use. Let's go over here, and actually let's go ahead and submit this. Boom. Okay, And then we can go over to the schedule browser and refresh it and find the live stream project here. All right. So keeping in mind, and what I'm doing is I'm going to look at this plan. This is the plan. So you kind of, just for review, you can see the timing stuff in the plan. And then the observation, just a single observation of this target with a 35-degree horizon. And then we're going to take 5 Bs, 5 Bs, and 5 Rs. Okay. So let me get this pulled out here. Back to help. Shoot. Here we go. All right. Glad I had that there. All right, so we can go here. Now, planning and submission, special features and text fields. I want to go over these. Each one of these things is an addition of a feature that is should probably be in the forms, but they're so rarely used that I didn't want to clutter the forms up, so I made it possible for you to trigger these things in observations without cluttering the form up with a bunch more options. So let me just go over these briefly, and you can find them now in the new help, planning and submission, special features and text fields. So how you work this is the description field and the image set. So let me go back here to the this. In here is the description field. So for example, I'm going to just shove this in front here, subframe 0.nn. So in the description field here, you'd put pound subframe 0.5. Okay, whoop, I misspelled that. With that, these 5 images will be taken with a 50% sized subframe. In other words, the center half of the frame. So each one of these options work like this, either in the image set, I'm going to go ahead and save this, or the observation. So let's take a look at these things. Okay. All right. Defocusing, again, it goes into the image set. This will defocus the images from where it was in focus. And this is a lot of photometry people use this. I should mention that one of the things that was done for 8.2 is the defocus has been reworked so that it will not move the focuser unnecessarily. The old defocusing, if you used it a lot, you could wear your focuser out. It was not a very good job on my part. So it's much improved now. It actually will remember even between observations a defocus. So, and then when it goes back to do a periodic autofocus, it'll remove the defocus, do the autofocus, reapply the defocus, and then go back and do all of its stuff. So basically it's permanent across all the image sets and observations. If you never refocus, it'll stay there forever until you put defocus 0 or until a different plan. So it's pretty cool. Readout mode. This is for cameras. There's support for it in ACP in the forms, but not in Scheduler. These are the things like RBI, pre-flash, or fast readout. You can actually tell it for the pointing exposures and focusing to use the fast readout of your camera automatically. But for the data images, you can specify the readout mode. So you can have, again, it goes into the image set, and you can tell it to use this specific readout mode. I should point out these options can be combined in the description section, so you can put any one of these in there you want, or combinations of them. So, all right. Now, if you want to prevent the plate solving of the images if you're doing high cadence and you don't want the thing to spend the time to plate solve your data images and you want to mass solve them later in your pipeline, You can do that by putting no solve in there. Again, if you're doing high cadence operations, you can put no preview in there. This is actually quite a win. And going from 8.1 to 8.2, thanks to Jeff Stone, he found I missed one part of the preview generation stuff. It was one line change in code, and it doubled the savings of overhead. So in 8.2, there's even a bigger win by turning off the preview generation for the web. And what you get when you do that in the web browser is you'll get, for the thumbnails, it'll say preview disabled. It'll be a black square with the words preview disabled in it. So, and you can pick up your cadence on series quite a bit with that. Okay, that's one of the other things I wanted to cover, both of those two things. And one last thing about priorities. That's always a question I get is, how can I force this thing to run? Well, you can give it hints and you can give it priorities, but it's really not easy to force things. If you have something, Tolga, any of these on one set, I don't know what you mean by a set, but on the image sets, you have to put them in every image set you want them to apply to. Okay, so that's important. And I may have lied to you about the defocusing. In fact, I probably did. If you put defocus in another observation or set, and it's the same number, it will keep it. Otherwise, it'll change it. So it's smart enough that it'll watch how much of it you have, and it'll switch it around, and it'll take it off for the autofocus stuff. And I might add, you should definitely test this as part of the beta, because it was a big change in how all that stuff's working. So priorities. Get back to. Thank you for the question, Tolga. I hope I did an okay job answering it. I don't think it was that clear of an answer, unfortunately, but let's. I'll get back to it if you need any more. Just say yes. You need more info on that. All right. So priorities. You have a choice with priorities, and right now it's saying all observers share priority scale. In the scheduler itself, there's an option on this, and I said I wasn't going to cover any engineering options, but it's important as a user to understand the difference between these and what it really means when you see one or the other there. Let me bring this up again so that you can see the option for the engineering people, you, the owner, or whoever. It says user priority normalization. Okay, I have it turned off right now. What the normal setting is, the scheduler can have multiple observers or users, and in order to keep things fair in a big situation where there's lots of different users, you don't want one user to put in, I want all my plans to have a priority of 1,000. I'll fix the rest of them damn people and have my stuff run come hell or high water. You can't do that with the normal setting for scheduler. Your priorities are yours within your plans only. So what the scheduler will do is it'll look at your highest and lowest priority and look at the range there, and it'll normalize it to a priority range of 0 to 1. And then it'll take the next user, and if their range of priorities is from 1 to 1,000,000, it'll take those and normalize them to 0 to 1. And then when it's calculating what it should do next, the weighting given to the priority is that 0 to 1 rating. So you can control the priorities within your own stuff, but everyone gets an equal shot at the system overall as a user. That's the normal way it works. It's a pretty interesting idea. I got this from the Liverpool telescope guys. They suggested it, and yeah, that sounds great. If you turn this, and by the way, if you close and reopen this form, I should be able, let's see, close and reopen. Now let's see what it says, priority. No, it hasn't. It needs to get refreshed. Let me go ahead and do that. That's an engineering change. I'm surprised. I don't know why I thought that would come back. All right, now let's look. Well, I obviously need to work on this. It shouldn't say that. It should say, with the scheduler changed like this. Oh, did I close this? Maybe that's my problem. There. All right, let's try that. Sorry about that. Let's do this one more time. I want you to see this work. Again, this is beta stuff anyway, but let's go back and look here. Nope, it didn't pick it up. I don't know why. That's an error, so I'll have to fix it. It should say that each user gets their own priority scale, and that I already know about that fixed time priority thing appearing there. If I turn fixed time on and back off, that'll disappear. See that? So I have a few little things to do on the forms yet, but bear with me. So the point is, you can either have the scheduler balance those priorities between users, or if you have a cooperative group of people that that won't try to bump everybody off with, and fighting over priorities, you can put everyone on the same priority scale, and it will treat everybody as though they're a single user for priorities. So if somebody puts a job in there with a high priority, it will affect the priority of everybody else. Okay, so those are the two modes I wanted to cover on that. Now, I will say this about priorities. It's a hint. There are other factors that are taken into account when the scheduler decides which things to run next. And if you want more information on that, you can go in here to the help, and under detailed description, and this is also in the current help, this dispatch scheduling of automated telescopes is the engineering white paper that describes how the scheduler works and how it makes its decisions. And that part is down in here, the efficiency function. So each one of these factors is figured into that what should I do decision, and priority is just one of them. You can actually fiddle with the coefficients in here by putting it on a custom efficiency mode thing, but I'll tell you, you will drive yourself nuts trying to figure out what it's going to do. Look at that expression, huh? That's priceless. So anyway, let me see. Tolga, if you set the readout mode on one set of images but leave it blank on the next set, does it stay there? No, it goes back to its default mode. Each image set has to have that option in it. They don't cross-talk to each other, otherwise you'd have chaos, basically. And the observations don't talk to each other. Everything is modularized in there. So if you have a green image set, a blue, and a luminance one in there, you would have to put the readout mode in each one of those. I hope that answers your question. I think it does. So it doesn't carry over. The only thing that sort of carries over is the defocus, and I may have given you bad information earlier. You have to put defocus into the image set or it won't do it, period. It will defocus, do the images one after another, and then in the next one, if you have the same defocus count there, it'll leave the focuser alone and run those defocused like that. But you still have to have that defocus in every image set you want defocused. If it encounters one without the defocus, it'll take it out. So, pending and deferred in the schedule browser. That's a good one. Okay. Let me see where we are time-wise. We probably have time for this. All right. It's a little bit, I think you mean here, deferred versus pending, and there's a red thing on the pending that is kind of hard, it's misleading, so it's been taken out. But pending means here, oh, see, these are just ones. All right. Pending means that it's eligible to run. It's something that is the last time the scheduler looked at that plan, it said, I can do it now. I might not. It might not be the best one to do, but I can do it. If it looks at a plan and sees that it's, oh, yeah, duh, Stevie says we can't see it. How about we go back here and there. Ta-da. Thank you, Stevie. I got to looking at the camera and didn't think about this. All right. So pending here means, let's look, live stream project. There's 100% here. Okay. Let us go to the live stream. And I see also that we have smiley faces over here. If you look, live stream, smiley face, pending, pending. It means that the scheduler looked at it and it decided that it could do this work. It could run it now. It might not pick it as the best one to run, but it can do it. If you see a sleepy face on here and it says deferred, it means that it doesn't meet the constraints. It's below the horizon. It's not within the air mass range that you specified. You specified moon down and the moon is up. Any of those constraints, if it doesn't meet constraints, and I mean meet them all the way through the whole plan, except for best efforts. In that case, only the first observation needs to meet constraints. But normally, without best efforts, if the whole plan can't be run within the limits that you specified, that's it. It'll put it to sleep. And it will tell you, let's resume all the projects and see if we can find something in here. Come on. Oh, I have to use this one. All right. See if we can find something with a deferred thing on it. Here's a finished one. Well, I'm not in a position to start the scheduler on this whole thing. Well, you know what? Let's get really wild and crazy here. Let us go back here and start the scheduler as a simulator. Oh, it's already running. Okay, so let me bring this back out as a simulator and put it at the next sunset time, something like that, and we'll run it. And we'll see what it does with all this. Boom. All right, it's faking startup now. While we do that, are there any other questions? Or if not, it'll take about a minute or so, maybe a little bit less, to open up. And then it should go and do a schedule pass, and we should find this grid of things here. We'll have some deferred stuff in it, and I can show you. Now it's doing an initial autofocus, blah, blah, blah. Okay, now off she goes. See what we end up with here. The first pass through scheduling usually takes some time, so, because especially this has quite a few things in it. One of them is huge. All right, while this is happening, let me see if when we refresh this, if we don't have some deferred stuff here. There, bingo. All right, let me go ahead and stop this now. All right, that was great. We got it. So, deferred. Let's have a look at the Bergman Nebula and see what's going on with this thing. We can look at it this way, deferred, right? Or we can look at it in detail. Oh, why did it say deferred here? Hold on, this is goofy. Something's, all right, where are we here? Live stream project deferred, that's interesting. Yep, there we go. All right, so horizon. This is not above the horizon yet, and it won't be until 0500 UTC. We started the simulation at sunset. 2 hours later, this thing rises above. its 35-degree target. So it's too low. So it has deferred this until, and so you'll also find out when it thinks it might be eligible again. So at this point, the scheduler will not look at this plan for consideration until after 0540 UTC. I hope that, Sean, I hope that answers it. If I go back here, we can look at another deferred one. 100. Why would there be some of them deferred and some not? That's intriguing. I'm interested in that. Let's see, in 100. Well, there they are. Okay, so this one says it's not going to be ready until 2100 UTC. That's way out there. I think this is because it's a daylight target right now. Anyway, I'm getting a little bit off topic here, but Sean, I hope that answered. The idea is that a deferred one has been looked at by the scheduler and knows that it can't run for a while. It can't even possibly do it because it doesn't meet constraints. So it just puts it to sleep, and then in a couple of hours, it'll throw it back into the bucket. It'll turn into a smiley face again, and it'll be eligible again. Yves LaRoche says it could be great to write a script to get all these time completions according to an observer's sky area observable boundaries. That sounds like an interesting project, although I'm not sure why the meridian flip time would be according to the sky area observable boundaries, unless you're saying it'll flip more often. I don't know why it would. It's going to flip when it gets to the meridian anyway. The rotator time, that's just how long it takes to get from one PA to another. Focus time, that doesn't change with the sky area boundaries. But you're right. You could write a script to characterize the entire observatory and then put that stuff in there. However, because I'm just one guy, and you only have to do this once when you install the software, right? So that script would only run one time. When I decide where I should spend my time, that wouldn't be one that I would put at high on my priority list because it only runs once and then you're done. That script would only run once if you changed a piece of equipment or something like that. So very infrequently, or once or twice only, maybe in a year. So since you can do that with a stopwatch and just work on your observatory one evening and measure the time it takes to do all this stuff and write it all down and put it in there, and then you're done. And then that you don't need it anymore. So, okay, Sean, I'm glad that made sense to you. That's excellent. I think I have covered pretty much everything. It's been 50 minutes. It's longer than I wanted to go, but this is good. We have people asking questions. I'm even more happy with this than I was last week's. These are all online. As always, if you haven't already subscribed to our channel, where is this? Firefox. Where is that thing? There, right there. There's a button in the channel like this. If you click on it, it will say you're subscribed. And then if you click on this bell like that, boom, now you'll get notifications for the next video. You're going to get an email from us a few days ahead of time. Anyway, and if you have already subscribed, you get a notification there. And also on the DC3 Dreams Communications Center, we always post the stream here. And when you click on this link, you end up getting taken to the email that talks about the next one coming up. So we do the best we can to advise people. And if you, thank you, Joe. I appreciate that, Joe Sardina. And thanks everybody who showed up. There were 12 people watching on this one being Stevie. Hi, Stevie. But this is really great. I'm going to keep doing these. every couple of weeks, I may switch to a shorter format where we're going to take a look at a particular type of observing and then how to make the best of the scheduler and or ACP for that kind of observing. If you want, I'm going to go ahead and put a suggestion box up on the Comm Center, the famous Comm Center here. I haven't done it yet, but I'm going to put a suggestion box in company and product, and I'll put a thing up here, suggestion box for live video streaming for things that you want to see, format changes, whatever. I've gone through a lot of the things that I had on my list now, but I want to keep doing this and try to address your guys' needs and help you to make the most out of our software. So that's the whole idea. Yes, you don't need your own YouTube channel to chat. I don't think so. You just need a YouTube account. You have to be able to log into YouTube and then go to our channel, and then you should be able to chat. If that's true, then it may be, this is what Eve says, if you look at the chat line over on the right. I will remember that and go check to see if I maybe set something in our channel that would prevent that without having your own channel. Well, actually, when you create a YouTube account, you get a channel, I believe. So maybe that's it. Anyway, you have to have a YouTube account, that's for sure. All right. Well, everybody who checked in from Australia, the US, Eve, I think you're in Canada, and wherever else, I appreciate you watching. If you've stuck with me all this time, that's even better. And we'll see you in a couple of weeks. Thanks.